So we'll have a look at some more questions. These come from 2014 Calculus 1 university paper. So we have question 28. So for question 28, we're asked for the indefinite integral of the natural log of x dx. So we're looking for a function which, when differentiated, gives us the natural log of x. If we think about 1 on x, so if we think about d is the obvious candidate here because 1 on x and natural log of x are inextricably linked. The derivative of 1 on x is not natural log of x. So that doesn't work. In fact, it's the other way around. The derivative of the natural log of x is 1 on x. So d is not right. The integral of the natural log of x, well, think about 1 plus c. If you differentiate that, that gives you 0. That's not natural log of x. E to the x plus c, differentiate that. That gives you e to the x. That's not right. X times the natural log of x, that doesn't work either because that becomes a product rule. So it looks like none of the above. We are, however, going to examine a little closer because we're thinking about the product rule. It'll give us a whole bunch of terms. It may be the case that this actually cancels down and that this is an acceptable integral of the natural log. So you have to be careful with these ones. You don't want to assume a product rule has a particular answer. You want to try it. So we're going to differentiate this. We'll do d dx of this. So the product rule, u prime times v, that will be the natural log of x, plus u times v prime, that will be x times 1 on x, which will be plus x on x, which is 1, minus the derivative of x, which is minus 1, and the constant goes away. This actually is the natural log of x. So this is a case where the question sort of tricks you. It gives you a whole bunch that immediately you think will either be too complicated or not related, and so none of the above looks very tempting, but in fact a is the correct answer. If you differentiate a, you get the natural log of x, thus the integral of the natural log of x is a. Okay, so let's do question 29. The indefinite integral f prime of x over f of x dx is which of the following? So this one you can do the derivatives if you're not sure. You can do all the derivatives and see which one gives you f prime of x over f of x as your functional solution. But this one is also a known one. This is the logarithm, right? So this is d. Whenever you have a derivative over a function and you're taking an integral of that, it's going to be the natural log of the function, or the natural log of the absolute. In this case, natural log of the function and natural log of the absolute work in the same way. So D is the answer to this question. Now, let's have a look at question 30. So we have, what is the indefinite integral of cosine of sine of x times cosine of x dx? So this is a little bit of a weird one. You could solve this using integration by parts. So you could break this up and do it that way. You can also just identify this by looking at the possible answers. So you can differentiate these possible answers and see which one gives you this function. So we're going to try that. We're going to try A. We're going to have cosine of x. This will be plus some constant. So when we do the derivative here, this is essentially a chain rule. So we differentiate the outside, multiply it by the derivative of the inside. So cosine becomes minus sine. This, let me say that A is such that, so the derivative then becomes minus sine of cosine of x multiplied by the derivative of the inside, which is sine of x. So this is not the thing we have at the top. This is not this. So A is not correct. We'll try B. We have sine of cosine of x plus a constant. Well, when we differentiate this, we're going to get sine becomes cosine. So we'll have cosine of x multiplied by the derivative of cosine, which is sine of x. This is not correct either. We'll have a look at C. This is sine of x plus a constant. So we differentiate this. Sine becomes cosine. This becomes cosine of sine of x multiplied by the derivative of the inside, which is cosine of x. Now this is exactly what we have up here. These are exactly the same. Therefore, the answer, in fact, is C. So the integral of cosine of sine of x times cosine of x dx is sine of x plus C.